All right, good morning. So today the objective is that students will be able to solve equations involving logs. And so the first problem I have here, you could solve using logs, or you could recognize that 16 and 8 can both be represented as a power of 2 or as a base of 2. So like 2 to the 4th is 16, 2 to the 3rd is 8. So there's multiple ways to solve this. So method 1, so if I have 16 to the x minus 1 equals 8x, I could rewrite 16 as 2 to the 4th. And then I could write 8 as 2 to the 3rd. And then if you have the same base, you can set the exponents equal to each other. So I got 4 times x minus 1 equals 3x. From there, distribute 4x, 4 times x, 4 times negative 1. Subtract 3x from both sides, and I get x minus 4 is 0. Add 4 to both sides, and I get x is 4. So that's method 1 on how to solve if you have an x in the exponent or a variable. So I would call this method 1. There's another way that you could actually do this, and I'm going to show you now. So we'll call this method 1. And the problem with method 1 is it does not always work. These numbers cannot always be written as the same base. Okay, so if these numbers are not able to be written as the same base, then there has to be another way, and that's what I'm going to show you now. Here's method 2. Method 2, rewrite the problem. We're going to get the same answer. We're still going to get 4. But this time, I'm going to take the log of both sides. Now, the reason why log of both sides works so well is that if you take the log of both sides, then the exponent comes down. This one might be kind of tricky. So what I'm saying is if I take the log of both sides, should have given myself more space, then the exponent can come down in front of the log. Okay. And then the exponent can come down. So that's one thing nice is that power rule with the exponents is if you take the log, then the exponent can come down. From there, there's a couple ways we could do this. This one's actually going to be kind of tricky. I suppose, well, I haven't done one like this in a while. There's a couple ways to go about it. I might distribute the log of 16 to the x and to the minus 1. So this would be x log of 16 times x minus log of 16. You know, a problem like this, I'm almost tempted to stop because this way is way more easier in this problem. It's because of that x minus 1 and the exponent that made this tricky. I could try. We'll see if it works. So I got x log of 16. Distribute minus log of 16 equals x log 8. From there, you want to get the x's on both sides, on the same side. So I'm going to subtract and move that over. There might be an easier way to do this, and I may just be having Monday morning not thinking straight, but so far it's working out. From here, we have an x in both, so I can factor it out. And then to solve for x, I would take log of 16 divided by all of this. This is not a very good example to start with. So if I type that in my calculator, scientific log of 16 divided by log of 16 minus log of 8. See, I still got 4. That x minus 1 is what made this tricky. Another way you could do this, which I still want you to do it algebraically. The way I showed on the paper was algebraically, but to check your answer, you could also go to Desmos and just see where they intersect. So you type what was on the left, log of, oh, I'm sorry, it was 16 to the x minus 1. Had to trick it. 16 to the x minus 1. And on the right was 8 to the x. And then you could look to see where they intersect. So this way it's almost more work. But they intersect at 4. It's just you'd have to zoom in and play around with the graph. All right, let's go back to the basics. I started off with the hard problem. Sorry about that. But here's one that's a little easier, and it's how do you solve 8 to the power of x is 32? And so there's 2 different methods. The first method is you write 8 and 32 as a base of 2. And then you could solve and say 3x equals 5. So x is 5/3. Or you could take the log of both sides, and notice this is much easier to solve than the one I had, which was x minus 1. All right, so this is a 2-day lesson. I'm not sure how far we'll get. We're going to start off with the easier ones and work our way to the more difficult ones. There are 2 practices I want you to complete. Okay, here, 3 to what power is 31? 3 is prime. So we can write this as 3 to the 1. 3 cannot be, or 31 cannot be written as a base of 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So there's no way to write this as a base 3. So then what do? We just take the log of both sides. So I take the log of both sides. The reason why, if we take the log of both sides, we could bring the exponent to the front. And then to solve for x, this is x times log of 3. We'll just divide both sides by log of 3. And I get x is log of 31 divided by log of 3. And this is when you need your calculator. I don't know why I just don't leave 2 tabs open. Log of 31 divided by log of 3. You guys are covering up the answer. I get 3.125749857. And then in the instructions, they say round to the nearest tenth. So I would say x equals 3.1. And then checking my work, what is 3 to the 3.1? I should get 31. I get almost 31. The reason why it's not quite 31 is because I rounded too much. So I encourage you to round or to carry that decimal place out as much as possible, but we almost get 31. Example number 2 is very similar. You want to get your base with your exponent alone. So we want to get our base and our exponent alone. We have that 3 there, so we're going to subtract 3 off from both sides. And I get 2 to the x. So 102 minus 3 is 99. And there's no way to write 99 as a base of 2. And 2 is as low as it will go. So I take the log of both sides. Doing that, the exponent can come down. And then to solve for x, I need to get rid of log of 2. It's times log 2, so I divide by log 2. So I get x equals log of 99 divided by log of 2. Type that in my calculator. Log 99 divided by log of 2, I get 6.6293. So I'll say around 6.6 if I'm rounding to the nearest tenth. All right. Number 3, I would subtract 3 from both sides. $90 minus 3 is 87. There's no way to write 87 as a base of 7. 7 is prime. That's as low as 7 could go. I take the log of both sides. I'm going to do both steps in one. So when I take the log, I'm going to go ahead and move the n plus 7 down. And I should put that in parentheses. So then, to solve for n, I'm going to divide both sides by log of 7. And then to solve for n, I subtract 7. So I need to type in my calculator, log of 87 divided by log of 7 minus 7. Let's see what that is. Log of 87 divided by log of 7 minus 7 is around negative 4.7. And then just to check my work, so we had 7 to the power of, and then I'm going to plug in negative 4.7, and it was plus 7. Then it was plus 3, and that was supposed to equal 90, and we get approximately 90. It's off because I rounded too much. So it's always a good idea just to plug your answer back in and make sure you get the same number. So what I did a second ago, negative 4.7, I plugged into my calculator 7 to the negative 4.7 plus 7 plus 3, and it was approximately 90. All right. Problem 4. I'm going to add 2 to both sides. 4 to the x plus 2. 14. 4 could be written as 2 squared. 14 cannot be written as a 2 or a 4 as a base. So I have to take the log of both sides. So if I take the log, the x plus 2 comes down. And I get log of 4 equals log of 14. And then divide both sides by log of 4. And then I subtract 2. Get x by itself. So I get x is log of 14 divided by log of 4 minus 2. I then type that on my calculator. And I get nearest 10th, negative 0.1. All right, there we go. Example 5. 2 and 3 can't be written as the same base. I take the log of both sides. That brings down the exponent. I'll show this as 2 steps this time. So I take the log of both sides. And when you take the log of both sides, the exponent can come down. All right, this is similar to that problem we had earlier. Trying to decide if I want to do the same thing I did earlier or try something different. It does no good to divide by x because I want x as a numerator and denominator. That won't help us. So I guess the only thing we really can do would be to distribute that log of 2. So I get x log 2 plus log 2. I distributed the log of 2 to both. And then log 3 minus x log 3. And then we want to get the x's on the same side and move those over. So I'm going to do plus x on both sides. Factor out an x. And then divide both sides by log of 2 plus log of 3. That involved quite a bit of work, so now I need to type that in my calculator. Have you guys been able to hear me this whole time? Okay. So I need to type in log of 3 minus log of 2 log of 3 divided by log 2 plus log 3. That was log 3 minus log 2. And I got approximately nearest 10th, 0.2. Plugging my answer back in, it was 2 to the power of, and I'm going to type it in as longer decimal this time. That should be the same as 2 or 3 to the power of 1 minus 0.2262. Oh, I see what's going on. Just doing that. I have to trick it, I guess. 1 minus 0.2262. Right? See how I got the same answer both times? So it's good to plug your answer back in and make sure you get the same thing. All right, next one. E. How do we solve E? When you have E, you take the natural log of both sides. Use a different color. I'm going to take the natural log of both sides. And what's nice, x minus 1 comes down. And what's nice about natural log of E is if you type natural log of E in your calculator, natural log and E cancel each other out, so you just get 1. So you get x minus 1 equals natural log of 6. So these cancel basically. Add 1, and you get natural log of 6 plus 1. Approximately 2.8. All right, so as our final problem, and again, this is a 2-day lesson on purpose. So there's 2 practices out there. The first practice is more of the easier questions for logarithms. And the second practice, I wouldn't say they're harder, they just take more work. So there are 2 practices. We're going to spend 2 days on this. I only got through concept 1 today, but there's concept 2. What do you do when there's a log? More than one log on one side? And then what do you do with equations with logs on both sides? Okay. And then there's your practice. Notice they start off pretty simple. On the practice, they do part of the work for you just to help you get in the right frame of mind. Then this one, I guess we should call that homework number 2. These are the more involved questions. Okay. But as our final exercise, we can solve this in 2 different ways. First one would be the common base. So I'm going to write this as 27 as 3 to the 3rd. So we have 3 to the 4x minus 2 equals 27 to the x plus 2. But I could write 27 as 3 to the 3rd. Three times 3 times 3 is 27. And then bases are the same. I set the exponents equal to each other. And then from there, I do algebra 1. Distribute the 3, subtract 3x from both sides, add 2 to both sides, and I get x is 8. Okay, so that's probably going to be much easier than method 2. Method 2, I don't know if it's even worth showing. It's going to be pretty involved. I don't think I'm going to show method 2 today since we're almost out of time. It's going to take longer. So I don't think we'll do anything quite that complicated anyway. So that's all I have for today. So hope you have a good day. Remember, you can do the first practice. We're spending 2 days on this. All right. Bye, everyone.